All right, welcome guys. This is the video for 6.4 example 6. So sorry, I had my little girl drawing on this. That's why it's a rainbow pen. So we are talking about still our surface area of a revolution. Okay, so example 6 says, set up and evaluate the definite integral that gives the area of the surface of revolution generated by revolving the curve about the y-axis. So our curve is y equals the cube root of x plus 2, and our interval goes from 1 to 8. So even though it says the y-axis, whoa, there we go. Here's a note. Remember, it doesn't matter which terms you use with surface of revolution here. Okay, so this problem may be done with either terms of x or terms of y. Okay, even though we're revolving about the y-axis with surface area, you don't have to integrate in terms of y. Okay, so let's draw ourselves a picture. We have our curve, and our curve kind of looks like this. This is 2, where that is not very symmetric. Let me try that one more time. It's a little bit better. Okay, and we are revolving it from the interval 1 to 8. So we're really just taking this piece right here and revolving this about the y-axis. Right? So you can tell that there's a gap between our our piece that we're revolving and the axis we're revolving it around. So since we have this gap right here, I know that means really this is going to create some kind of washer type shape, right? We're going to have a hole in the middle. So that's our curve that we're revolving. All right. Now, like I said, it doesn't matter if we do it in terms of x or in terms of y, but because we've done an example already in terms of x, I'm going to change this to in terms of y, and it might be easier for our integration in the end. We could do it either way. Just our final integration might be a little bit easier if we change this to terms of y. So to do this in terms of y, I first need to get my equation into terms of y. So we're starting off with cube root of x plus 2. So y minus 2 equals the cubed root of x. So x equals y minus 2 cubed. Okay. Also, if we're going in terms of y, I should probably make my interval of integration into our y values as well. So right now, the interval they gave me was from 1 to 8, but I want to change that to be terms of y so that I can integrate the right way. Okay, so my bounds, I'm just going to plug them into my equation. So y equals the cube root of 1 plus 8, which is not plus 8, sorry, 1 plus 2, which is 1 plus 2, or 3, and y equals the cubed root of 8 plus 2, which is 2 plus 2, which is 4. So instead of integrating from 1 to 8, we will integrate from 3 to 4. So let's set up this integral now. So our surface area is 2 pi times the integral from 3 to 4, r of x, which is our curve, our radius, so y minus 2 to the third power, times this arc length formula, so the square root of 1 plus y minus 2 to the third. Oh, I messed up. Sorry, guys. In our arc length formula, this is where our derivative goes. So let's do x prime real quick. That was the one piece I forgot beforehand. I'm sorry. So our prime, x prime, chain rule. So 3 times y minus 2 squared times the derivative of the inside, which is just 1. So in here we have 3 times y minus 2 squared, all squared, dy. Okay. So now I'm really wanting to integrate this. I need to simplify it first. I can't integrate it with it looking the way it does right now. So I'm going to focus on the inside of my square root for just a second and simplify just my exponents. I don't want to expand this, and you'll see why in just a minute. But I am going to simplify those exponents. I have a power to a power, which I can simplify. Okay, so y minus 2 cubed square root of 1 plus, now I have 3 times y minus 2 squared, all squared. That outside 2 exponent can be almost distributed to everything on the inside, right? So I would be able to square the 3, which gives me 9, and I can square what's already being squared, so it's to the 4th power. Okay. So now in our other problems, we've kind of been manipulating, because at this point in our other problems, we've been getting rational functions that we can split and take the square root of and all of those fun things. On this one, we don't have to. This is a much easier problem than that. And if we had done this in terms of x, we would be doing that with our rational functions and trying to split fractions and take the square root of pieces and things like that. We don't have to do that here. Okay, I want you to use u substitution. So pause the video, try to use u substitution here, and I'm going to tell you your u should be 1 plus 9 times y minus 2 to the 4th. So pause the video, give it a try, come back and see what you did. Okay, if I put u to be 1 plus 9 times y minus 2 to the 4th, my du would be, the derivative of 1 is 0. The derivative of this is a chain rule, 36 times y minus 2 to the 3rd. And then it's a chain rule, but because it's du, we have to multiply by dy. Okay. Which is the derivative of that y minus 2 piece. So now, if you look back to our problem here, I'm going to highlight some stuff. We have this y minus 2 to the 3rd dy in the original problem. Y minus 2 to the 3rd dy, those are going to cancel. So we really just have to get rid of this 36 right here. So du over 36 equals that y minus 2 to the 3rd dy. And now I can substitute back into my integral. So we have 2 pi integral 3 to 4 instead of y minus 2 to the third dy, that will end up being du over 36. And then we just have the square root of u, which is u to the 1/2. I can bring that 36 out front, so it's 2 pi over 36 integral from 3 to 4 of u to the 1/2 du. Now we can integrate, so 2 pi over 36 times the integral of u to the 1/2 is 2/3 u to the 3/2. So 2/3, and I'm going to replace my u with what I have set for u, 1 plus 9 times y minus 2 to the 4th to the 3/2, evaluated from 3 to 4. Okay, and now it's just simplification. So we have, 2 pi over 36, which is just pi over 18, times, if I plug in 4 to this mess in the middle, I get like 1164.0208 minus, plug in 3, 21.0819, which is about 63.4966 pi, which is like 199.48047. And that is units squared. Okay, so this was a good example to show you how we would integrate in terms of y instead of terms of x. But again, it doesn't matter which one you do here. You could have done this in terms of x. Your integration would have just been a little bit different, and you would have needed to simplify some more rational functions there. Okay. So that's it for 6.4. This assignment will be due next week, and we'll start Unit 7 as well.